All right, so the question was about nesting, say, functions inside of your get y. So for instance, if I have multiple integer values or something that I'm expecting to get out, and I want to transform it to a float, and yes, Saban posted here in the chat about a titled short float. This is a sort of transform that he made that will give us a title. So if we go back to the notebook I was at a moment ago, which was the scalar regression. I know we're kind of going off topic, but it's still kind of relevant. When you're working with these point values, I did not want to do that. One thing you'll notice is show won't work. And so the bit of code that is in the chat right now lets that show batch function work. And essentially you define sort of a transform block that'll turn essentially these images and these outputs into, actually here it is right here, into sort of what we're wanting. This is a little bit different, I believe, than the one that Saban has posted, but the general idea is, so with any of these, I know we're going super off topic.
No, this is relevant too. I had a question on this too. So yeah, I'll let you finish and then ask you that.
Cool, absolutely. So to sort of center myself again. So if we're doing regression with points, with something where we're trying to show, so, you know, it could be image regression of some degree, defaultly fastai won't per se work yet. And so we can create a sort of sub type. In this case, we use an integer here that has a show function itself. For an example of what this looks very similar to, the concept is kind of, in a way, this is where I sort of draw back to every time that I'm looking at something. I'm going to Vision Core right now. So as we know, we use PIL images, right? And so we use PIL image whenever we want to use it as a particular item. It inherits from this PIL base, and this is what pillow base looks like. And this is what any sort of item base is going to look like in the library. We have this create function, and we have this show function. Now, the show just simply says whenever we call a show batch, or a show results, or a show anything, how do we want the model to look? Or how do we want the data to look? And the issue with the regression problem here is we don't actually have that capability yet. It wasn't built into the library. And so what we've done here is just given a show value, because we already have the value, hence why we pass in an integer type here. But we don't need the, but we still need a show function in particular. Along with this, if we want to do this sort of show, we need to create it into some sort of a transform. And what the transform allows us to do is give that one number an encodes and a decodes function. Encodes will be run whenever we're going through the pipeline and converting everything over to, you know, tensors. So we get the data in, then it runs through different encodings until we finally get a tensor. Decodes is used anytime we want to return back a peek as to how the data is looking. So whenever we do like a show batch, if it doesn't, it won't look exactly how the model will be seeing the data per se. We'll bring it back just far enough to where we can see what the data looks like. That's the whole point of decodes. It's not an exact representation of the data. It's a close enough representation.
So both your example and Saban's example, instead of creating the title number short, you could basically in decodes just written capital int, right? In your case. And in Saban's case, the capital float. Both those are titled.
Yeah, absolutely.
From fastai, right? Okay.
Yeah. Now, show title is actually a function in fastai. That's why we're inheriting from it. So if I go over here to show, might be, yeah, show title. We have show title and we have show titled image. And all that's really doing, if we look at the source code, is it's just using matplotlib. And whenever we call something, we call an image, we'll give it some sort of a title, essentially. And that's going to be the label. So that's all this is doing here, the show title function. And so we're just saying that, let me get back to it. We're inheriting from that function. Saying we pass in an integer, it's going to use the show title functionalities. And whenever we do show, call show title with our particular number's precision and use it as a string. And then we can go ahead and pass that into our decodes. That way fastai knows, okay, whenever I try and show this value, it has a decodes function, so I can look at it. And now, if we pass this also into our getY, because this will just run it as a transform, it shows our numbers. Now you notice it's not quite integers. That's because we don't really do integers whenever we're dealing with these tensors. We do floats. You know, let's go back to the classification example. It's all a list of probabilities that we eventually get to 1. So that's sort of what's happening here. fastai will also basically say, if you're doing anything with regression, it'll use a float to use, I believe it's to use the CUDA a bit more efficiently.
Correct me if I'm wrong here, Zach. What you're showing here, like you said, is never used per se in the model, right? So the 56.0, if you actually, instead of returning and decodes title float short, if you just return int capital I, it will return 56. But you're
actually no. This will be well, yes. Actually, yes. Sorry, because we have the .int here.
Right.
Yes, thank you. So the general idea behind the more advanced to float method is like, you know, if you wanted to expand this to just be integers or just be floats, or
right, like I was expanding into lists.
Yes, exactly.
Right.
And that would be modifying this encodes value, or this encodes function.
And like, even if your show batch doesn't work, if your transforms are right, your learner can still learn, right? This is just for seeing. Yeah, right. That's what.
Yeah. So like, you know, we have this big issue right here, but we could still train a model. You know, notice I made a data loader off of it. It didn't throw me any errors because it can still do batches, just we won't be able to view the batches.
Right.
Now, in this particular instance, what that would mean that I would do instead is I would do probably the single best debugging tool that's ever existed in the fastai library. And that is datablock.summary. That is what I did down here. I guess we can go into that too while I'm at it. For those that don't know what this is, Sylvain actually created this. It will run through every step of the data block and describe what is being done, and that way you know exactly where the issue is in your data. You know, because before we just had this giant long list whenever we're trying to train or something or build the data loaders that says, you know, right here, none type object is not iterable. Well, what the heck does that mean? Well, none type. I only have a print function here, and it broke on my getY. That's what this is meaning right here. All right, let's go back and adjust this into something that works. So we have, you know, back to our original regex labeler multi-label. If I run this again, this learned summary will go, or this data block summary will actually go through, build a data set, set up your initial pipelines for your image block and our multi-category block, build one complete sample end to end, show what the sample was, and then it'll attempt to build a batch as well. And this way we can sort of, decode exactly where issues will be. And so if we did this on, this particular scalar regression problem, it wouldn't show an error because we can still build our batches. Any questions about that per se, or that functionality?
And just to add to that, like I think passing the verbose command for like data loaders and data sets is also a really helpful thing. It kind of shows you what is being built on the side.
What command? Sorry, I haven't even actually heard of that one, I don't think.
I think your data loaders and data sets, when you're kind of building it from that level, you have a verbose command. So that kind of prints out all the things extras.
Yes. Okay, I understand what you're talking about now. Yes. I wonder if that's actually here. I don't think we have it here per se.
I think it's VRBO. Or maybe this is from...
I know what you're talking about, though. I've seen it before.
Right. Okay.
I think it's in Transform Data Loader.
There it is. Verbose is equal to false on the top line after num workers.
Yes. Yeah, there it is. I see it right here. That's sort of another way to debug it. And that verbose, I believe, is actually taking parts and bits of what's happening in the data block summary, too. So that's sort of a way for, if you say don't want to go through the trouble of getting a show function working because you trust that you've done it well and you can grab a batch and make sure that the batch is right, then this might not be needed to go through and build, this show float option.
Right. The only pain that I realized is it's hard to visualize results at the end of the day also.
Yes, it is difficult to visualize the results. So that is where it's beneficial if you're trying to visualize something. But let's go back to the original topic, which was nesting various functions in your get-y. So in this particular problem, which is key points, I have a data frame where it will go through and grab me essentially 17 particular values. This is an entire row for my data frame. We want to ignore this 9 because that just says how many values are there. And the points that we want to care about are these next 16. Or next 18, sorry, because we have 9 points. And these are all coordinates, but this is not coordinates. This is not what we expect coordinate points to look like. This is just a giant row. So I need to make a get-y function that'll go through and do that for me. So let's look at what this get-y is doing from start to finish. So first we can see that we call this image to key points where we pass in my file path. Let's go back up and look at what image to key points is doing. Image to key points, with how this data is set up, all of my values live in a text document that is the file name that was passed in, .cat. So the first thing we're doing is an inner function that just returns our cat file name. And then from there, we generate a numpy array of that file, and that is where this array stems from. So now we have essentially 2 nested functions inside of our get-y. Well, all right, I have these. Now I want to convert it into, a tensor that looks sort of like what we're expecting. We'll need to make a separate points function that takes in some array that we get from key points from this gen from text. And so here I can go through and run, whatever function I want that operates over these raw inputs and separates it to however I want my model to be. And now my y is this 9 by 2, 2 by 9, sorry, tensor that my model is expecting to run key points on. or image regression. Does that sort of make sense as to how you can work with it? So what we're getting in this particular get y is whatever we're passing in to our get x, essentially, to our getters. So in this multi-label instance here, we have, get image files as our get items. And so what that is assuming is anytime we get one item, we're going to be getting some sort of path that points to an image. And then it's up to our get y and to pretty much figure out what to do with it. So we have, our regex labeler here. So it takes this file name and goes through and extracts the file name from it, or the particular class from it. And, we could modify that further with like, a get x or something if we wanted multiple of those, where say we did get maybe not a file name, but we had a custom get items that returned a folder, where we then wanted to like, grab the first few instances from the folder if we had multiple x's. So does that sort of answer your question? I hope. I know I went off on a weird tangent there.
No, yeah, that does. Yeah, I'll give that a shot and see how that works.
Awesome. Yeah. So
yes.
Awesome. What were you gonna say? Sorry, I cut you off there for a moment.
And I was just saying I had 4 columns, each of them as numbers, and yeah, that was the thing. Like I was trying to do something like what you have done, converting it to float, but on all the 4 columns individually. And I think now I have a better idea of doing it. So the easiest way was just to combine it into a list and throw it in there.
Absolutely, and then just transform that list.
Exactly, yeah. We'll give this a shot. Yeah, that's helpful.
Awesome. Are there any more questions sort of about, let's go back and re-share my screen. Oh, wait, there we go. Never mind. I'm recording my screen. That's why I can't show it. There we go. The chat's over there. Were there any more sort of questions about the regression or about get y that I can answer while we're sort of on the topic? Or even multi-label. I know we just finished that video, but if there's any questions about any of those, I can answer that real quick.
I have a question about multi-label.
Sure.
So basically multi-label is just not like 2 categories like cats and dogs, but instead like 100 categories. That's what multi-label means?
Multi-label means I can have any number of categories show up, and those number of categories could be infinite. So whenever we're doing our initial classification, right, so that's, image is dog. It's either a dog, or it's a cat, or it's a chicken. That's what our normal category block is doing. And this is, as we mentioned earlier, running a softmax and an argmax on our predictions to get us one final result that we want to use. Multi-category block and multi-label is under the assumption that you have an image that could have any number of classes show up in it. And so the goal of the model is now to see first, to look at all of the classes and all the possibilities, and then pick from those which ones it believes shows up in the image. Does that make things a little clear?
And it could be like 2 or 3 classes in the same image, right?
Absolutely.
Just to add to that, I think it's good to kind of Google and see what the difference between multi-label and multi-class is.
Yes.
Having dogs, cats, chickens, but each individual having only one of them, that's the multi-class problem. A multi-label is the one where in one image you have a dog and a cat and a chicken. So that differentiation is kind of well explained, I think, in scikit-learn. If you just Google that one, it explains it pretty well there.
Yep.
Oh, okay.
I'll go ahead and paste that into here. And then I'll also go ahead and paste that into our thread. And I'll go ahead and edit this with the link once we're all done with the videos. But yes, it's very easy to get the 2 names very confused. Because, it's label and then class.
Yeah, it sounds pretty loosely used too. So
exactly, and so
yeah.
it's kind of a nightmare. The better idea is to just understand, how both of them work, and then correct people to the correct nomenclature if you can. Otherwise, just make sure that they're kind of on the right track. Is generally probably the better idea. But anything else?
With the this is just kind of exploring the multi-label thing that we just looked at right now.
Sure.
So in our situation, we were just trying to predict. It's a right. So in our situation, we were just setting a threshold of, let's say, 10%, and then you were trying to evaluate whether a new image, what the probabilities are.
Yeah.
But you're using binary. First of all, you're using multi-category, which basically means it's one-hot encoding. And in this scenario, the one-hot encoding will just be one value, right? Because it's just going to be a single label. The question is basically like, can you replace multi-category with a category block and replace BC logits with just BC? In theory, I think sounds right. Or am I missing something?
Well, let's go ahead and try that.
I mean, I managed to break my notebook, but I'm just wondering, like, maybe there's so much that goes happening under the hood. So I'm just wondering if there's something very obviously wrong. Yeah, sure. Yeah, that's right.
So multi-category expects a list. Category expects a string. And that's the main difference. That's why we have this unhashable type list. Why? We have, let's look at this pipeline here. Regex labeler.
You're not sharing your screen again, Zach.
Oh, shoot. Okay. Oh, yeah, that's right, because it's... Why is it not sharing? Oh, share screen. There we go. I haven't been sharing my screen for a bit, haven't I? Oh, gosh. Okay. We're back to a screen. Sorry about that. If anyone's confused at any point, it's in the video. I promise. I knew something had happened, but that's okay. All right, so I basically set it up to where we have, the category block you described, but we still have the multi-label transform nested inside of it, right?
Right.
And if I call summary and just say, try and run and build a batch of data, we can see that it breaks at this level.
Right.
Regex labeler to our multi-category list, where we just converted to a list, and then it attempts to categorize. And we get this unhashable type list.
But I'm saying you can drop multi-L here, right? Because you don't need that. And this is not in terms of running the code. This is just in terms of understanding.
So
because multi-category.
Yes, absolutely. Yeah, absolutely. This is just pets.
And so, then even if you still end up using the multi-accuracy or accuracy multi,
I don't believe it will work, but we could try. So if we do cross entropy loss flat, I'll just fit it for one cycle and we'll see what winds up happening. Who knows? It could very much work.
Because all you should end up with is the probabilities, and then instead of applying the softmax, you just want to apply a sigmoid to each class, right?
Yes, ideally, is what we should be seeing. But let's go ahead and take a look just in case. Sorry, it's taking a little bit of a moment, but as you can see, it didn't work. And the reason for that, if I had to presume, more than likely deals with the fact that it needs to be paired together. Before we can do anything. So let's actually,
I see. Okay. So you're using cross entropy. So cross entropy has to be paired with sigmoids. I mean, with softmax, right?
Basically.
Right. So that's okay.
Another way to quickly run that real quick, and I'll go ahead and show this too, is in sort of how you debug this sort of issue and experiment with it if you don't want to wait for a maybe a section for the, you don't want to run through an epoch. There we go, that's what I want. I'm going to go ahead and grab a batch of my data. And then I can do what's called with torch.nograd, which doesn't store the gradients. I can just get outputs. I can send this batch into my model. So I can go, learn.model batch. I just want to make sure.
Batch 0, right?
Yes, batch 0. Just want to make sure that the model's set to CUDA, which that should have done that. And so now I have this output from my model, right? And so we can go ahead and look at it. This is just, our raw output. And if we try passing this into accuracy multi, we can do flatten check, pass in our input, which is our batch at 0, and our output, which is our out. And you'll notice that we fail.
So because out is not the same size. Okay.
Yeah, so let's, just because this is sort of definitely more advanced, let's take a look at what happens whenever I am working with the multi-label and see sort of why that's a thing. So if I now grab a batch of my data and go ahead and make, my model with BC log just flat. Go to the model. I think I made a mistake right there, but that's okay. And go ahead and get its output. I believe that the shapes are a little bit different.
Right.
And so if we do batch 0 versus the flatten check, interesting. Well, this should have worked in my head at least. But maybe it's not now for whatever reason. Interesting.
Because what is out? Can you check out? I'm
so
sorry,
out,
not
oh, the input?
You shouldn't be, you're comparing batch 0 with out, it should be batch 1 with out, right?
Oh,
or rather
yeah.
out with batch 1.
Doy, thank you. Over here losing my mind. So, all right, so now we have the flatten check there. Let's go run the regular classification. Give me one moment. My roommate is checking in on me real quick. Hey, man, what's up? Yeah. One moment.
Hi, Savan. Do you mind posting the link to that discussion that you were pointing?
All right, I am back now. All right, I am back now. Sorry about that. Minor welfare check. But I heard asking Sylvain about something.
Not Sylvain. Sylvain was there. He just mentioned something about a discussion being there. So with respect to the transform blocks, I just wanted to see if I missed something there.
Oh, it was about the, yeah, okay, it's recording. I believe it was about the titled floats.
I think it was either in the chat or I will try to figure out, then send the link there. Okay.
All right. Thank you.
Awesome.
And about the multi-label, you can think you have fruits and the color. And let's say you have a banana with a yellow color, but you can have another apple, but you don't specify any color of it. So you put multiple labels for the different sort of problems, and you try to measure them and try to find them instead of whether it is in that category or another category. So that's the really little bit of difference, using multiple labels to identify objects or group them in a different way. That's how I usually interpret it.
Got it.
Cool.
All right. So
okay, I will not interrupt anymore, but try to find the link for you, and success with the lectures.
Absolutely. No,
Thank you.
please interrupt, especially if it's, something related to the conversation.
Okay, thank you.
Absolutely. Lectures. Oh gosh, it's like I'm a teacher. I'm not a teacher, guys. I promise.
Are you sure?
Anymore? No, not really. Honestly, but that's okay. All right, so let's check the flatten check again now that we're actually doing this right. I set it back to the single label so we can go through and run the output. So yes, so here again, we get that issue, and I believe it's due to batch 1.shape. I think it's due to the fact of how what that should really look like is something like a 32 by 1 or a 32 by 37.
Yep, sounds good. Yeah.
Yeah, that sounds about right. And that's why we get this flatten check assertion error, and why you can't mix and match accuracy multi with cross entropy.
Mm-hmm.
And so you should keep each of them together.
Yep.
Now, obviously the other bit that you could do if you just wanted to get the raw outputs and work with that is, I believe, at the tail end of the model, what you essentially could do is predict will go through and run any sort of decodes that are happening and stuff. And cross entropy loss flat, I believe, we're going to look at this, but I'm hoping, yes. It has a decodes function. And what do we learn about decodes? Decodes are running anytime that we want to get back our outputs. And so our loss function is run every single time that we're using the model, even if, it's just in general. And so we can see that cross entropy loss flat, while it's not calculating the loss per se, we're not doing this activation and checking the softmax, we are still getting the argmax. And so that's why it doesn't work. Because no matter what, our model is now going to be grabbing the argmax whenever we call learn.predict. Does that fully finish explaining why it doesn't work?
Right, yeah, yep.
Awesome. All right, any other general topics that we kind of would like to go over?
Nothing else from me right now. Thank you.
Absolutely.
Thank you so much for doing that, and feel better.
Absolutely. All right, I'm going to go ahead and stop sharing, and I will stop the